Okay, I will be go over the basic for the digital lab. I pick it up number 5. The thing is that more simple. Okay. Hopefully the guy already understand it. Now, you understand it the job technician in the company. What you doing? First thing, like I given you the circuit board like that one. What you need to do? I run the test. Okay. You will be running the test to test this circuit. And the test program, engineering, we do it. You don't have to do. Okay? However, when you run this part, that means the circuit board good. If they fail, your job will be fix it to make it pass. That's the main thing for technician in any company. That means you have to fix the circuitry. So that's what we want to do a minor different way for training for tech you. You cannot say, okay, I done all of the lab, okay, and you can be done. No, now will be different. Okay, before we start it, you know how to build a circuit. First thing, for example, you build for U1, then all of the Y U1 have to be done. Okay, you get a marker so you know which one already done. Then U2, all of the Y U2 must be done. And the last one U3. Okay, same thing. After you build a circuitry, don't try to taking the wire. Never. Just waste the time. And that is not really happen in the company. The thing in the company, the circuit board they build. However, the wire in the middle, okay, of the layer. So they cannot broken. Okay. Only thing they wrong will be either U1 or U2 or U3. So for the test, okay, and you have to understand where they apply and where they measure the output. So that's why you trading the signal will be going. Okay. In this one, the first test will be testing loading, right? That's number 1. Okay, and the test title. Load 0101. Okay, like the math data. Zero x 0 and for the peacock, A1, A2. Now, first thing for understanding, the signal will be out from where? Okay, data, raw, PA, 0, 1, 2, 3, 4, 0, 3, 0, 4. Okay, so now that will be true U1. That's for a little more clear. However, U1 is U1, not B. Okay, okay. 2, U2, 2, U1, B. BC, okay, 0, 1, 2, 3, 4. That is for the test, number one. So when you run it, okay, they will bring it out, expected value. The 1, 0, 1, 0, 1. And measure value. Whatever. If they measure 0, 1, 0, 1, that means the test is passed. Okay, now the problem is I sorted U2 pin 14 to route. You know that U2 pin 14 here to route. So when you run it, they pass or fail.
Let me look at my board.
Mr. Pham, I have a question.
Yeah,
If pin 14, well, let me back up. You're loading 0101. So at the very beginning, if you is like at PA1, pin 2, is that 0, and then 4 is 1, and then 6 is 0, and then 8 is 1? Is it lined up like that?
now pin 8, pin 4 will be 0.
8 is 0?
0, 1, 0, 1. That's number 5.
Yeah, I was only reason I was going to answer your question is just that I was trying to see from the top which is which, because you said
PA, pin 0, 4, 1, 0. Okay?
okay,
PA, pin 0, 3 equal 1. PA 0, 2 equal 0. And PA 0, 1 equal 1. That's number 5.
okay, and then you said that on your U2 you said 14 you grounded it.
Exactly.
So whatever you ground is going to come out to be 0.
Yeah. Then the question is, when you run the test, it's a pass or fail.
It
Fail,
will fail.
Yeah, I would say it would fail because that,
fail.
Okay, now it failed for sure.
Mhm.
Okay, so look, you see you measure 0, 1, 0, 1. However, when you run, they will coming out 0, 1, 0, 0. Correct? That means 14 you want it to be a 1. However, the measure will be 0. The thing is we route it.
Right.
Can you guys follow me?
Yes.
Yes, sir.
Okay, now you tell me what do you want to do to fix the problem?
Well, take the ground off of 14.
You never know I routed.
Or you mean like Mr. Pham, like work backwards? In other words, on U2, you're looking at pins 11, 12, 13, 14. So work backwards and look at pins
12, 14, 16, 18. Well, 3, 4, 5, and 6,
yeah,
right?
exactly.
3, 4, 5, and 6, and 18, 16, 14, and 12 on U1A.
But pin
Gotta follow the line.
pin 3 on U2 comes out of U2 and go to the output of QA for pin 14. So you need to see what you measure at U3. I mean, excuse me, U2 pin 3. Is in other words, is U2 pin 3, what does that measure 1 or does it matter
0.
0?
Okay, now by looking into the expected value and measure value, okay, I know some wrong at pin 14 U2, right?
Right.
Or some wrong with U1B pin 9.
Right. You got the wrong answer.
Correct?
Right, right.
Mm-hmm.
That pin supposed to be 1, but it's wrong. Now, that's what I try to teach you. How do we find out if your pin 14 not working?
Oh, so when you said you looked at U2, I mean U1 pin 9, you got the wrong answer. So then you need to go back to, I mean, this is all in hindsight, but you got to go backwards to U1 pin 11 and see if you got the same input. In other words, you got an output on U1 9 and you want to see if you got that same value at U1 11. Then you want to go back, depending on what you get, then you go to 14. Then you go back to 3. You're working backwards.
That's what I want to talk to you. Okay, 2 ways to troubleshooting. One way you can go from input to the output. You know it's wrong on the 14 here. That means you can go in from PA pin 2. Logic 1. Okay, you go to pin 18. Logic 1. Okay, you go to pin 14. They're not one, right?
Right.
So you know it's wrong right here.
Mm-hmm.
Okay. And you know the pin 3 you okay, right?
Mm-hmm.
Right.
So you get it wrong right here. Okay. So if you get it wrong right here, you go from the input to the output, and now you can go up here.
Mm-hmm.
11 and pin 9.
Mm-hmm.
One way. The other way, you go backward. I'm looking into the expect value. I know I wrong on pin number 9. Right?
Right.
So I go back.
Mm-hmm.
I'm looking into pin 11.
Mm-hmm.
Now, if you're looking in pin 11 is correct, what can you do? Okay, now I try to repeat it. I measure L1 pin 9, the logic 1, no, logic 0, right? So I go back to input pin 11. I measure pin 11, I get correct. That means logic 1. What can we do now?
U1 is defective?
In 14, U2.
No, forget that 14-0 for now. I say some, you say some wrong
Oh, okay.
on pin 9.
Okay.
Then you go back to take pin 11.
Basically, Mr. Pham, you're saying on U1B, you have the right input at 11, but the wrong output at pin 9.
You have to fix the problem. You have to tell exactly.
Well,
Replace
you would,
U1?
wouldn't you check, wouldn't you, the first thing you always do is check your ground and your power source, right? On any IC?
For sure. You take power pin 16 or ground pin 8, for example, or 14 or pin 7. That's normal. However, now you get wrong pin number 9. However, you get pin 11 input correct, telling me what you want to do.
Replace U1?
Not yet. You
Check.
have to make sure, you know, that in general, you say input is right, output wrong, right?
Right.
That can you one. However, in here, that's not enough.
What about checking pin 19 to make sure it's grounded?
Exactly. In order for the output Y1 equal the input A1 of U1, pin 19 must be round. Right?
Yeah,
So that's why you have to check U1 pin 19. It's round. Now, it is round, then now you have to change U1. Okay? So normally at work, you give the board to the assembler. I like to change U1. And they will be changed for you. After they change for you, what can you do?
test it.
Test again. If now it is part, that means you fix the problem.
Yep.
Okay.
Hey, Mr. Pham,
Yeah.
only thing that seems weird, I hear what you're saying. What seems weird is, and I said you got to check pin 19, but coming out of U2 pin 14, you have the wrong answer.
No. Forget about that. Right now, I just talking about pin 9 you get wrong.
Right,
However, if you pin 11 you get it right,
right.
then what can you do?
Oh, I see.
Like we said, you have to check U1 pin 19. If pin 19 round, then pin 9 equal pin 11. If it's not round, that means they're not equal.
Well, and U1 is actually U1 UB is unique because it actually has 3 grounds, right?
Pin 19.
Yeah, it's different.
Now, when you give the board to the assembler, I want change U1. I am your supervisor. I asking you, why you change U1? What you can answer? You say, okay, I measure pin 9, logic 0, however, pin 11, logic 1. I said that's not enough information. To get pin 9 equal pin 11, pin 19 must be round. So the answer will be, I take pin 11, I get logic 1. Pin 9 not. Then I take pin 19 round. That's why I want to change U1.
Mhm.
But Mr. Pham, is that correct? Because you still got the wrong, I know you said you didn't want to talk about it, but you still got the wrong output on the other IC.
You mean for we sorted, right?
Yeah, you still got
Okay,
the,
don't forget about that.
It's no longer shorted.
No.
We have two
general.
different scenarios.
In
Yeah.
general. Okay.
It's no longer shorted.
Yeah, we don't care about that for now. In general, I said you take pin 9 wrong. You take pin 11 right. That's not enough information to telling you one wrong. You must be check one pin 19.
Mhm,
If it's 0, then now you can say you want to change one.
right.
That means you have to check, make sure the right input and the wrong output, then you can change the IC. Okay? So, the troubleshooting, you can go from here. Now we go sort this one again. We can go from A to 1 to U2, U1 again. When it fails, you can take from input PA to U2 to U1B. Or you can go backward from U1 pin 9, 11, 14, 3, 18, 2. Okay?
Yeah.
However, the way we want, I'm looking input U1, output U1. I know they're wrong on pin 9. So, first thing, I check U2 pin 14. U2 pin 14 supposed to be high. Right?
Mhm.
Right.
Okay. If yes, then what? What you want to do?
Yeah.
You check right here. U2 14 for logic 1. If yes, what can you do?
You go
you
back
go to 11
you go back to
or 3.
back to 3 again and check.
No.
Well, you got the right input but the wrong output.
No. Right now I say, I take U2 14 at logic 1.
Right.
And I get it. Yes, I get it.
Run the test again.
No. You say they already failed it.
Oh, okay. Okay.
So
So it's 1 at 14, it's 1 at 11, and it's still 0 at 9.
I don't care. However, you take pin 14, you want it to be high. And they say, okay, you get high. What can you tell me? That's what I bring it up a different way. Troubleshooting. Instead, you go from input to the out, or the output back to the in. Now I go into the middle. If you take
Check pin 11.
exactly, you know, you get pin here, okay? High, okay? That means correct. Then check U1B. That pin number 9. Instead 11, right? You can say 11. Okay? Equal high. If yes, then what?
Check pin number 9.
Perfect. U1B, pin number 9. Okay? High. For sure they will be wrong, right? If no, Then take what? You take 11, you get a logic 1. However, you want B, benign, wrong. If no, you take A1B, pin 09 for low. And the final will be, if yes, remove and replace A1. That is the way how to troubleshoot it. Okay?
And Mr. Pham,
Yes, sir.
the only problem I have is, and I thought I heard a student mention it. You said initially when we started all of this, you said you grounded U2 pin 14.
Yeah, but the thing is, 14 have to be wrong. Right?
I mean, did you ground it? I don't know. Did
Yeah,
you put
that's what if I ground it. Then let's say U2 14. Okay? Now they have to be what? Low.
if you ground it as low?
Okay. I route it to be low. Okay? Now U2 pin 14. Correct?
Correct.
Okay. So take U2 14. For sure you get it low. Now, if yet, then what can we do? You take U2 pin 3, correct?
Correct.
Okay. Take U2 pin 3 for high, right?
Right. You want it to be high.
Yeah, that's what you want. If yeah, then what?
Check 18. You want 18?
You now. Right now, you know wrong 14, correct?
Correct.
You take pin 3, right?
Right.
You get high.
Right.
Then what can you do?
Make sure it's loaded properly or what?
I want you to tell me what you are doing. That's what you have to show me. When you say, okay, my lab working perfect, that's what I try to make it not working, and you have to tell me what you want to do.
Well, check the ground first.
Okay, you can say you create a route you I see, right?
Mm-hmm.
And power, that's okay. Forget that.
Okay.
Now we go into the problem here. Okay? I say take you to pin 14. You see it low, the thing is we routed. If yet, that means for sure if yet. Then you say, I go to take a pin 3 up you 2. You want it to be a high. You get high. What can you do?
From whatever other tests, make sure it cleared and then loaded properly.
No. Right now, this is a first test. You're just telling me what you want to do. You take
Check pin 9.
Yeah, that's what I was thinking. Pin 9.
exactly. You have to make sure they load it, right? Then you have to say check. Okay. Yêu chu pin 9 equal 0. Correct?
Yep.
Okay. Before you say yêu chu is not working, you have to prove the input requirement, they must be done. Okay. Now, yêu chu pin 9, you want it to be 0, correct? What else?
Clear.
Oh, you want to check the clock.
Okay. Did I say asking for clock, right?
Correct.
Okay. So also, okay. Then yêu chu pin 9 0. Okay. Then check. Yêu chu pin chu equal B C L K. Correct?
Yes.
Yep.
Okay. If okay. Then do what?
Check pin 10.
Pin 1 is
Then check.
1. Clear.
Perfect.
Clear.
Check. Yêu chu pin 1 equal
High.
1.
Yeah.
Finally, you say, okay, yêu chu. That means remove and replace. Remember, in the company, they say remove and replace yêu chu. So that's why they're using R and R. Any question? The thing is what I try to do, make sure after you get the board already built and you get your program already, when you run, it failed, then you're able to know what needs to be done to find out, okay, which one is wrong.
Thank you.
Okay, any question? That means normally you take U2 14. Okay, I copy here. Now you take that, you get high. And what you want to do? If you get a 14 here, they supposed to be high. Okay? And you take here, you get high. But pin 9 get 0. What can you do? Okay? I can
Okay.
tell you. Okay. You say check. Okay. A1 pin 11, right?
Mm-hmm.
Yes.
Okay. If it's high, then check A1 pin number 19. Correct?
Yep.
19. You want it to be low. Okay? If yes, ah, you want. Again, if you want to change the IC, you must be true. They get the right input, but they get the wrong output. That is troubleshooting. Normally, the way we do it, we go in the middle. Okay? If it's right, then you go to the out. If it's wrong, you go back to the in. That means we break it in the middle. Okay? If you go from the out to the in, take it longer time. Or the in to the out, same thing. Normally troubleshooting, we will be get the take in the middle. If it's right, go to the out. If it's wrong, go back to the in. That is the way. Okay, any question, anything? Now, remember, that is the way. How can we do it? Okay? And in here, so basically, you already know how to do that. For the timing, any questions regarding into the timing?
Can you please show us how to do that again?
The timing. In the timing here, okay, you can see the first thing is clear 0. So you go clear 0 right here, okay? Basically, don't care, right? QA, QB, QC, QD. They not give a logic at all. That means they don't care. Okay? However, when clear 0 and you're looking on QA, 0, 0, 0, 0. Okay? And the input A, B, C, D will be the same QA, will be clear. Okay? So when the clear 0, You can see dry at this point here. How come they not display for QA, QB, QC, QD? Who can answer that? You see that? Clear zero. And supposed to be A, QA, QB, QC, QD. Must be zero. But they not. See that? Why? Who can answer that?
Load is high
Clear zero, output have to be zero. But they not, right?
because the load is high.
What do you mean?
Load is 1.
No, we're talking about clear. Here is clear. One not clear, zero clear. Active low. My question is, I said again, clear zero, how come QA, QB, QC, QD don't care? You see, that means they not data here. Who telling me why?
So the clock,
Perfect. The thing I did, I see control everything by the clock. Whatever you want to do, you have to get the clock. So that's why when the clock going 0 to 1, you see that? Then output now will be 0, 0, 0, 0. So that clock will be controlled. Like
Mr.
apply the clear equal 0. If you not apply the clock transition, output is not 0.
Hey, Mr. Pham, just before the clock, those dashed lines on
Nothing,
QAB.
don't care.
Okay, that's what I wanted to say. That those dashed lines mean no, don't care.
Right, don't care. They don't care. Whatever. So if you apply the clear, if you not apply the clock, output cannot be 0 until clock going 0 to 1. You get that?
That means the entire
Yep.
IC, this entire IC is clock controlled.
Exactly. That's what we already talking.
Okay.
Anything you want to do, they must control by the clock. Now, next will be loaded. You see, load 0. Load 1 not loaded. So when it's 0, can you tell me A, B, C, D, what number?
I'm sorry, what was the question?
When the load equals 0,
Mm-hmm.
what number input A, B, C, D?
1, 1, 1, all ones and a 0. D is 0.
Yep.
What number?
1110.
I'm not a computer. I'm human. I want decimal.
Oh, you want a hexi? Okay.
Decimal.
Oh. Oh my goodness. I'm too
0,
tired.
1, 1, 1.
Oh, let me think for a minute.
What number?
7.
It's got to be
7.
7. All right.
7.
7. Right?
Hmm.
7. Yeah.
Okay. We're human. We're talking about decimal. So when the you loading 0. And now you have to waiting for the clock, right? 0 to 1. Then the output will be 7. 0, 1, 1, 1. You see that?
Yep.
However, you need a clock anyway, right? How about a clear?
It's 1.
Yep.
The clear must be 1.
1.
Yep.
So that's why, if you understand the timing, you know how to troubleshoot it. They give a requirement for the input and they telling you the output. Okay, so after you loading, the number coming out will be number 7. You see that?
Yes.
So now they start counting. You apply the clock and they count 7 count will be number 8, right? They're counting up. You on 7. They apply the clock, they go to number 8. Number 8, that means 1, 0, 0, 0.
Yep.
And make sure load must be 1 and the clear must be
1.
that requirement. Okay, and now if apply the clock next, they go to number 9, correct?
Mm-hmm.
Okay, and this is number 9, 1, 0, 0, 1. Okay, and now if you apply the clock again, what number?
0.
0. Perfect. That means they start counting from 0 to 9, and 0 to 9 go forever if you keep apply the clock. Now, the
Oh, we
out,
got to remember this a BCD counter, right?
yeah, BCD, that means the binary code decimal. That means binary, they working like decimal. Decimal only 0 to 9 to 0. Don't have any number greater than that. And the circuitry, if you're looking on YouTube, RCO, okay? RCO, that's the output coming out. Now, RCO output normally low or high?
Normally low.
Low.
Normally low. When they go high?
At the completion of the cycle,
Toggles.
After output will be 1, 0, 0, 1. After they reach number 9, right?
Mm-hmm.
That means complete counting. They go high. So if I looking at the output RCO, I see go high, I know this will be number 9. They already reached number 9. Okay, then they start over. That means the output RCO go back to 0. Okay?
And so on the schematic, the ripple output is that PC05 by chance?
Okay, now on this one, right?
Yeah.
Ripple carry out. Go high when counter reach number 9.
Uh-huh.
Okay.
So its output is PC5, right?
Yeah.
Okay.
Okay. Let's see. I can write in here. Okay. RCO yêu chu RCO going high when okay counter reach 9. Correct.
Yes.
However, if you want to verify, you have to let the counter keep running, but you have to using the oscilloscope. Then you can see that go high, then high again, keep going. But we don't do a manual. The thing in manual, that means you have to connect the oscilloscope to pin 50. Okay? We are automatic. That means we have to do something else. That means I adding U3. U3 that's a D flip-flop. Okay? Preset connect logic 1. Clear PD01. Connect to clear U3. That will be telling you. Okay? When you clear, then U3 pin 5 must be 0. Correct?
Yes.
You're clearing U2 and U3 at the same time.
Right. You clear U2 and also you clear U3.
Yep.
That's why in here
Yep.
they already say that
Oops.
U2 and U3. Okay?
Yep.
Now, U3, they connect not to pin 6 back to pin 2. How they work?
That's when you're gonna when everything is done, it'll toggle, and whatever value you had on 5 will go to 6. In other
Okay.
words,
Now,
they change from 0 to 1.
Yep. It'll go back down.
then
Or,
U3
or go around again.
pin 6 connect
Okay.
to U3 pin 2.
Mhm.
Okay? It will be toggle when get
The clock.
clock.
Yeah.
Okay?
Mhm.
So when you counting number 7, this 0. It go to number 8, it's 0. When they go to number 9, okay, that means you get this signal coming out. Okay? And that signal like the clock for U3 then PC pin 5 have to be go to 1. Okay? That's why in here, after you test counting, you have to test RCO. Okay? Equal. How? Okay? That make clear to you guys?
Say it again?
Any question?
Oh,
Okay, now,
Okay.
next I'm talking about program.
okay.
So normally, when you write your program, first thing you create a new project, name everything. Then you copy this file. Okay? Copy this file. Okay, Control C. You copy. Okay? Now, I try to see okay, you say new project, right?
Mm-hmm.
And you can type DLab 05. I don't care something else. Okay? And you're looking for browse where you want to save. Okay? Now I say okay. And you say next. Take it out. Take it out. Empty. Finish. Okay, then right click on the project, add new item. You see that? C plus plus. D lab 05. Say okay, add. That means your file already for added.
And
Okay,
don't forget to put your clear.
exactly. You have to right click on the left property. Common language. CLR, right?
Mm-hmm.
Apply. Okay. Now, you already copy from Excel, Control V. Pass them out. Okay, everything here, you can change the date you want. Okay, like that's the day you're doing. Okay, change to your name, not my name. Okay, and D lab 05, whatever. Okay, now the thing is, they given you the load test. Expect math because you don't have a that one, okay? Then you have to apply the clock and make sure you get the load or whatever, okay? In here, you want to code, you looking for, okay? Whatever here, 0, 0, 0, clear will be 0 or 1. Clear 0, they clear. So, on your program, okay, this have to be one file, correct? I given you here, okay? Clear equal 1. Load equal 0, okay? And you get data 0, 1, 0, 1. Then you apply the clock, okay?
It shouldn't be 0x05.
Yeah, that's what I was wondering.
It's not 15.
Just a minute. Oh, PD, sorry. Okay, thank you. I correct that.
Yeah, I was gonna mention that too. We do have a,
That's a 0, right?
Yes.
However, you have to write to port D.
right.
So you want to load, that have to be 0, right?
Mm-hmm.
That have to be 1, right?
Mm-hmm.
So basically 0 at 0, 1. All right? Now you need to write, copy, write port D. MR, or clear. Okay? Then you apply the clock. So that's done for step number 1. So you want to do a step number 2. Okay? Then
Mm-hmm.
you follow that one, right?
Right.
And Okay, now in here, expect data, math data, พี่ก็ U1, U2, okay? So if you want to do a test number 2, copy test number 1, right?
Right.
Just change whatever need to be changed. Okay? Now, we're talking about, okay, if I want to test for that clear, okay? I copy that, copy. Now, let's see, test for clear. Test clear U2, U3, test number 4. Okay, test number 4. Test clear. U, U2, U3, right?
Yes.
Let's see, make sure I correct. That's number 4, U2 and U3.
Mm-hmm.
You don't have to write port A. See that?
Mm-hmm.
Not able. Okay. So load in here, clear. Okay,
Mm-hmm.
clear. Then that one have to be 1, right?
Yes.
Clear have to be 0. So 0, I 0, 2.
That's on test number 4. U2 and U3.
Uh-huh. That's number 4. Okay. That will be, sorry. They don't want me to do. Copy here. 1, 0, 0, I 0, 2. Okay, here. Expect data. They supposed to be 0. However, you need to look in port C here. Right here. Okay. So you want U5 to be 0. U3Q. Okay. And 4, 3, 2, 1 output, you want that to be
0.
okay. Expect data 0,
0, X, 0, 0.
0, 0. However, math data 0, I quad.
1F.
It would be 1, yeah, because you'd mask the 1 because you're looking for logic 0. Right?
So we want that output.
Right, to
So
be
the
0.
math have to be 1, 1, 1, 1, 1, 1F. Correct?
Mm-hmm.
Yes.
Okay. Expect data 1 and math data 1. Okay. So let's see. Port A. That That's clear. You don't have to do anything. However, port D drive 0802. Okay. 0802.
Delete port A.
Port A nothing. If you're looking into here, we're doing step number 4. Port A, see that? Not able. So you not try to port A.
Hey, Mr. Pham, I know what you just said, but if you did write the port A and make it 0x00, would it affect anything?
No, the thing is, right now, you clear. They don't care about the load, right?
Yeah, I understand it, but I'm just asking for just general knowledge. What if you put
Yeah, you
zero-
can write it whatever here. Doesn't matter.
Okay, all right, okay, I'll leave it at that.
Okay. The thing is, you say clear higher than low. So when clear active low, then load can be 1 or 0, doesn't matter. You can write whatever you want, but it not make sense.
You know, zero clear is the highest priority. I get it.
Okay. That's why if you understand when you can enter either 1 or 0, we don't want you to do that. I want you don't care. Okay. So that will be 1 app, you want to show right for the apply the clock. Okay. Now, let's see what next I want you to do. I want to test for 15. Test U3 toggle.
Would you please explain about the test number 5 before that?
Now, right now I'm talking about what will be confusing to guys. If you want test U3 toggle 15, okay, copy this guy. Copy. Paste them out. Now, is it 15, right? 15.
Mm-hmm. It's just you three.
U3 toggle.
Mm-hmm.
Okay, expect data you're looking on port C. Okay, Q U3 Q0. Now toggle they will be go to
1.
1. Okay, and this will be telling you the other one you don't care. And that expect data will be 0, 8, 1, 0. Right?
Mm-hmm.
Yes.
Math data.
15.
What math data equal?
Zero X 10.
10.
0 x 1.
0.
Perfect. Okay. So that you can say expect data 10. Math data 10. And whatever. Okay. So let's see what that one now not able. 15 here. Also, they will be don't care. Right? You don't have to write anything. Oh, make sure,
Shouldn't be 1.
yeah,
1, 1, 1, 1.
that have to be 1, right?
Yeah.
All of them.
All of them are 1.
Oh, yeah. So your guy do better than me. Okay? So 0x, right?
Mm-hmm.
Okay. So now you can say write for D. And you don't have to apply the clock, right? If you're looking into the circuit coming here, okay? When they go high, they don't have up, they don't need any the clock transition. Okay? So that's why you don't need the clock.
But don't it show the clock for everything?
Now, for the input output, but not the output RCO. If
Not
you
that.
look in here, they go high, but they don't have a deadline here, right? That means the clock. No.
Okay.
Basically, when it count up to 9, automatically they go up.
Oh, because that's a pulse.
Right. And that will be done. Now, I'm talking about counting up. Talking about counting up. Flow diagram. Okay. If you want to counting up, then you will be, how many tests will be?
9.
First thing they count
0.
1. No, count to 1.
Yeah.
Okay. 2, 3, 4, 5, 6, 7, 8, 9. After 9,
0.
0. Ah, okay. So if you have to do the program counting up, you have to type in 10 tests, add 10 more tests. To count from 1 to 9 to 0. Okay? That means you have to type in 10 more tests. However, last time we already talking about C++ function. So that's why I want to help you to get the function. First thing, you understand if you want to get the function, you have to get the declaration or prototype. Void, counting up. Void means no return. Okay, that we call function declaration or function prototype. Okay, and the function prototype, then you have to get a function definition. Now you go down here. After the end man, okay, after end man, this is a function definition area. So you copy on the same thing on the declaration, void counting up, but no semicolon. Then you open the bracket here. Open. Start testing counting up 0 to 9 to 0. Get title. That is to counting up 0 to 9, 0. Map data. Pick up you. That basically coming from here. That counting up here. Okay. Basically, they clear already. So now, in here, they counting up, there will be 1, right?
Yes.
2, 3, 4, 5, 6, 7, 8, 9, and 0. Okay? So this what we're talking about, a decimal. You can use a decimal, or if it's not in here, you have to say, oh man, they don't want me to write. So the number 9 will be 1, 0, 0,
1.
1. So you can say 0x09. They understand. You're using number 9. They also understand. So that's why. First thing, you need to write to put D. Go into here to see when you counting. Okay, what port A, B, C, D? Counting, don't care here. However, number 9, I think you have to follow the timing. Load 1, okay, and clear
1.
1. 0x, 0x, right?
Yes.
Okay, so in the program, write for D, 0x, 0x. That makes sure clear equal 1. No? 1-0. Is it correct? Looking for D.
For D, 1010.
Oh, load 1, clear 1. Okay, sorry. Okay, 0F, right? Clear equal 1. Now, you start the loop for J equal 1. If J less than or equal 10, you increment J. That means J plus plus. Okay. First thing inside, you have to say that plus plus. The thing I did is I run the loop 10 times. If you don't say that number plus plus, you cannot see the that number. And if you want to count, you apply P clock. Now, if they less than 10, that means they go 1, 2, 3, 4, 5, 6 up to number 9. Then you want the output to be 9. 1 to 9. That's why you say expect equal J. Otherwise, what the number L? That means J equal 10. Then you want output to be 0. And then you read or whatever. Okay? So that will be done. So now, in your program, okay, let's see. In your program, when you go to tab number 4, and you start tab number 5. Okay, 1, 2, 3, 4, 5, here. Start, set, counting up. Only thing what you do, you just say counting up. That's what they call a function code. So, okay, when they run through the that number 4, they hit into the counting up. They call a function call. The program will be jumped into the function definition here, and they run here. Okay? After they done, they going back. Okay? And they will be running
15.
at 15. The last one. So, normally, they're using the function. They try to make separate program to do one thing. Okay? Like later on, you can see I get counting up, out counting down. Okay? Then I have to get the each one will be a function. Okay? And that will be function have to get decoration. And also have to get the function definition. Okay? So that is
Hey, Mr. Pham, did you need a clock in that? Did you need a clock?
counting up, right?
No, go back to where you were at.
Now, they jump to here. You get a clock right here.
Okay,
Okay?
all right. So you didn't need to put the clock at that other
No,
spot.
no. The thing of that will be inside that function.
Okay,
Okay. You see that you get the that number 4. Done. Okay? Then when they hit into counting up function, they not execute in here, they jump into function definition here. They will be done here. Okay? After they done 10, so they going back into the main program. And they will be execute that number 50. Okay, any question?
and if everything goes all right, it should put a big pass on there, right?
Exactly.
Mhm. Yep. Thank you.
Yeah, you're welcome.
Thank
And
you.
hey,
Thank you, Mr. Pham.
okay, try to make sure it's clear for everyone. Okay?
Yep. Thank you.
Okay, you're welcome. Okay, we stop it. Okay?
Okay. Have a good
Have a
long
good day.
weekend, everybody.
Have a good holiday. Okay? We'll see you
Okay,
later.
bye.
Mr. Pham.
See you on
Bye.
Tuesday. Bye-bye.